Today you are going to learn a little bit more about functions and how to determine whether a relation is a function or not. So let's review. What is a function? A function is a relation in such that it's a special type that for all the x values there's only one y. So that phrase one and only one means for each input there only is one output. So how do you know whether a relation is a function? If it's a special type of a relation where it has that one-to-one, it's a function.
Yeah.
So these are relations right here. Now how do you know which one is and which one is not a function?
You put your x
Well, this one, see this x value?
in. Not a function.
It's paired up with two y values. So this one, because the x value, the input or the domain is repeating, it's not a function. So this one is no. The next one is a function. All of these x values are unique. None of them are repeating, so that one is a function.
We're halfway done.
Now, the next thing is, and these will be like your homework, 5 through 12. If I give you a few relations, these are equations, but these are relations. How do you know whether the equation is a function? What I want you to do, you're going to solve the equation for y. If it is unique, then it is a function. How do you know it's not unique? Well, whenever you take the square root or fourth root or sixth root of each side, it's that plus or minus. Remember like in Algebra 2, when you had a problem like this, if it said,
X equals root 4 or something. Plus or minus.
okay, what did you do here? You took the square root of this
Yeah,
and you wrote y is plus or minus
2.
2. Okay, so in this case, it's not going to be a function because for this y value, there's two y values here for that x value. So if you look at these two problems, A and B, and I'm sorry they're hard to read, but look at A. A says, we're going to do them individually, you have 4x minus 2y cubed plus 5 equals 0. If I ask, this is a relation, we're comparing x and y. If I ask you, is this a function? Most of you guys would want to graph it and see if it passes the vertical line test. Well, this is really hard to graph. So another way you can do this is you solve the equation for y. Get y by itself. How would you get y by itself? There's a couple things you could do. You could bring this over here, or you can bring these two over there and then divide.
Probably easier to add the 2.
And do you mind?
Do I mind?
Do you guys, some people don't like to do
I
that.
thought it'd be faster. Just
It is faster.
cleaner.
Okay, then what would you do?
Divide by 2
Let me write it,
over there.
yeah. Okay, then what?
Divide by 2. And then cube root.
And then take the cube root of both sides, right?
Yeah.
Cube root of both sides. So this answer, y is equal to the cube root of 2x plus 2.5. So this is unique. This is a function. But look at this one right here. B. You've got y squared minus x plus 1. If you swing x and 1 over, you end up with y squared equals x minus 1. Now you're going to take the square root of both sides, and what do you get? Plus or minus x minus 1. So there's two values here. This is not unique. So this one is not a function.
So anything that has a plus or minus is not a function.
Now how do you get the plus or minus? When does it become a plus or
When you
minus?
get a square root or a
When-
radical of 2.
When the y value has an even power. If it's odd, then you don't write that plus or minus. Does everyone understand that? So basically, these are the proofs of whether or not they're functions. That's the reason why it's not a function. But if you wanted a shortcut way, if the degree of the y value is even, it's not a function. If it's odd, it's gonna be a function.
That's always, there's no special case for that.
Okay, this part's easy. How do you evaluate a function? So if I give you a function, this is a relation that is a function. So we get to use that f of x. If I say, what's f of 3?
So plug in 3 for
You
x and
plug
solve.
3 in for x. 3 is your domain, you're gonna put a 3 in here. And what is f of 3? What do you get? F of 3 is what?
10.
Square root of 10. Now, you guys are all so used to grabbing the calculator and taking the square root of 10. No, I don't want that. This is an exact answer. Once you take your calculator and give me a decimal, you're estimating it. Because there's no way you're going to be able to put all those numbers. Now, if it said the square root of 8, I'm sorry, the square root of 4, the square root of 9, then yeah, go ahead and do that. But the square root of 10 is a decimal, so we're not going to bother with that. How about B? What is f of negative 5?
It's root 26.
What do you get?
Square root of 26.
Yep. Square root of 26.
2, 13, yeah, so you can't do anything.
Okay. How about f of p? What would you write? F of p,
On paper, let's see. So p
you're going to
squared
put
plus
p
1.
in for x. So it'd just be p squared plus 1.
So when they give you another variable, it's the same, it's literally the same problem, you're just putting that
Right,
variable in.
right. Now look at this one. Look what they're giving us here now. This is f of p plus 1. You're going to put this in wherever you see x, you're going to put p plus 1. So what do you have here? What are you going to write? P plus 1 squared plus 1. Now can you simplify this for me? Can you square p plus 1 and then add 1 to that?
P squared plus 2p.
Uh-huh, go ahead.
2 squared plus 2p.
Not 2 squared,
Or p squared, sorry. P squared
p
plus
squared
2p.
plus 2p plus 1 plus another 1
So
is?
P squared plus 2p plus 2.
Yep. So this is basically what you're doing.
Can you take, do you want to take a p out of, can you take a p out of that one, that answer?
No, no, no,
Oh, so that 2 doesn't
no,
have to be.
uh-uh, no. Let's do one more, and then I'm gonna tell you something. What would f of x plus h be? You're gonna plug this in for x, so what do you have? X plus h squared plus 1. And what is x plus h squared?
X squared was 2hx, or xh,
XH.
whichever one you want to put.
Really, you're right, it should be hx. That's okay. And that would be it. Now, what you're gonna notice is this and this problem were from Algebra 1 and Algebra 2. And then these ones are gonna be more like the pre-calc. Okay, so it's getting, the material is the same, it's just getting more rigorous. All right, now this back page here. This is called the difference quotient rule. It states that f of x plus h minus f of x divided by h this is called the difference quotient rule. You're going to be asked to evaluate this function with this difference quotient rule. Okay, now I would do this in pieces. I would evaluate f of x plus h. If you plugged in x plus h into this function, So you've got, this is your rule right here. You're gonna plug x plus h in to this function right here. So in other words, x plus h squared minus x plus h plus 2. So what I did was I'm sticking this x plus h into this function right here. Wherever I see an x, I'm gonna plug in x plus h. So let's clean this up. What do you get when you square x plus h? You get that, and then distribute the negative. There's nothing else you can do. So all of this is x plus h into this function right here. So f of x plus h is equal to x squared plus 2xh plus h squared minus x minus h plus 2. So now I want to do, what is f of x? If I asked you to plug x into here, what is f of x? If I asked you to put x in here and x in here, you would get x squared minus x plus 2. So now, see if this makes any sense to you. They're asking you to take x plus h, which is this, and subtract this. And then divide all that by h. So we're going to take all of this, we're going to take x squared plus 2xh plus h squared minus x minus h plus 2. That's all that this is, x plus h. We're going to subtract this f of x. And we're going to divide everything by h. So we took this piece, and we're following these directions right here. We're taking x plus h, and we're subtracting f of x. So what do we have to do with this negative? What do we have to do? We have to distribute the negative. So what do you get when you distribute this negative? You have x squared plus 2xh plus h squared minus h, or minus x minus h plus 2, and then watch, minus x squared plus x minus 2 all over h.
And just take out an h. Right
Now
here.
what cancels? There's a bunch of stuff that cancels here.
That
The x
plus 2
squareds
minus
cancel.
2, plus 2 minus 2, yeah.
The x's, the minus 2 plus 2, and what's left is,
2x squared, h.
what's left? You have 2xh plus h squared minus h all over h.
And you just take out h.
Take out an h on top. This is why you have to have a C or above in Algebra 2 to do this class. This is now canceling these h's, and your final answer is 2x plus h minus 1.
Oh my god.
That's one of the more difficult questions that'll be on this next test, this one right here.
It's not even that it's hard, it just
You're
takes
gonna
forever.
I know. Okay, what does determining the domain of a function mean?
Figuring out what the x is.
Figuring out what the x can be. So it's best to see what it can't be. Now, problems like A. What is the domain of the cube root of anything? It's all real numbers. Why is it all real numbers? Because there's nothing you can't take the cube root of. You can take the cube root of positive, negatives, and so forth. Can anyone think of another function where the domain is all real numbers? Can you give me some other examples? I'll give you one. Y equals 2x plus 1. How about x squared plus 3?
Why is it all
Because there's no, you can square any, this is a parabola, this is a line. You can put any number in for x. There's no stopping you. Now, where are the ones you're gonna have trouble with? That. No, this one. You can cube any number, positive, negative. What numbers are you gonna be here, or what equations I should
Radical
say?
equation.
That equation right there. Why is this a problem? Why isn't the domain all real numbers on this one?
Because you can't, what if it's integer, like negative 3?
Can I do this? Can I plug negative 4 in here?
No,
Why not?
I think that is square root of a negative.
Because you can't take the square root or any even index. You don't want a negative number here. So for if it's a square root or fourth root or sixth root or eighth root or 10th root or any even root, what you do to find the domain is you take what's underneath here and you want to make sure that whatever you get under here has to be positive. How can you say that expression has to be positive? What number can we set that greater than or equal to?
2.
0.
0. You're gonna set this expression, we want this, instead of saying positive, we want it to be greater than or equal to 0. So in other words, if we subtract 2, x has to be any number that's greater than or equal to negative 2. Let's see if this makes any sense. So here's our domain shaded. Here's a picture of the domain.
Okay.
So does this make sense? Meaning, can we plug in negative 2 in here? Yes.
Yeah.
Negative 2 plus 2 is 0. We can take the square root of 0. It's 0. Any number, what about negative 1? Can we put a negative 1 in here? Yeah. Yeah, but can we go anything to the left? No. So how are you going to write this domain in interval notation?
Bracket negative 2.
Good. Bracket negative 2, comma,
Infinity.
infinity,
Parentheses.
parentheses.
So that's all you have to do for these problems.
For if it's a square or fourth, sixth, eighth root, yeah, you set what's underneath it greater than or equal to 0 and solve. And then write it in interval notation. What did you learn about fractions? Fractions cannot have what in the denominator? 0. Can you have 0 in the numerator? Yes.
Yeah, that's okay.
You can't have 0 in the denominator. So what number is going to generate a 0? X cannot be what?
Less than 1.
It can't be less than 1?
Okay. Because 0 minus 1 would be negative 1.
All you do is you
Oh,
set this
wait.
equal to 0.
Just kidding.
X cannot be just the number 1.
So is
It
a
can be-
whole?
So it's a whole at 1. It can be negative. It can be any negative. You can have a negative number in the denominator. You just don't want that number, 1.
So how do you write that? Parenthesis
How do you
1?
write that? Anyone think they
Is
know?
it like parenthesis 1, comma?
Go ahead.
You'd have a 0 right there. I thought you can't have 1.
You
It's
can't.
going up to 1. If it was a
It's going
bracket,
up to
that'd be
1.
including, I should put a parenthesis.
If I would have had a bracket at 1, then I'm including it. So that parenthesis means skipping it. Okay? So we're skipping it.
So you're only doing that for the denominator, you're only worrying about the denominator? for
Yes,
those?
only denominator fraction.
Okay.
Okay, and these next ones are called piecewise functions. Okay, I want you to understand how this is written. It's saying this is a function. It is a function, so we get to use this f of x. It's saying we have two parts to it. We have this function, and part of it, f of x is equal to 2x plus 3, if the x value is a number less than 4. So see this comma? It's saying if x is less than 4, let's draw a picture of x less than
It's like
4.
a logic problem.
So any number that's less than 4, you're going to use this function, 2x plus 3. But if the number is between 4 and 10, if it's between 4 and 10, if it's between 4 and 10, 4, 5, 6, 7, 8, 9, 10, you use x squared minus 1. So let's see if you understand this. So if I said evaluate this function
You're gonna do
for
the
f of 4,
x squared minus 1.
yeah, you're gonna put 4 into this one. So 4 squared minus 1. What's 4
15.
squared minus 1? 15. What about f of 10? Where are you gonna put 10 at? Up here or here? Bottom one. 10 is in this bottom one.
99.
So 10 squared is 99. So what if it said f of 3? Where would you put 3 at? In the top one. 2 times 3 is 6.
What do you do if it's greater than 10? Does that what
No
do you-
solution.
No solution.
No
right?
solution. Good question. What if it said evaluate f of 11? No solution. So what would f of 3 be?
Oh,
9.
whoops. Just kidding.
Do you get it? Okay, now, this is asking you, what is the domain? This is your numbers that you can use. Like Nick said, what if it said f of 11? You can't use 11. You can't use anything greater than 10. So what is our domain? This is our domain right here. Now, can you write this in one shot?
Do you want this in interval?
Yep.
Okay, so parentheses, negative, infinity, yeah.
Comma.
4 parentheses.
Nope.
Wait.
10 bracket.
Oh, you don't do it as separate? You don't
Nope.
like union it or anything?
Nope, this is one problem.
Okay.
This is one interval notation. Now, a lot of people want to do that. They want to go like this. Negative infinity, this is what I get. But how do you write this in one shot?
Just cancel.
Just like that. So don't write it like this. This is simpler.
Okay.
Last thing, this is easy. Do you guys know what this greatest integer function means? Has anyone ever seen? This is not absolute value.
Are you sure?
This is absolute value. This is greatest integer. Does anyone see the difference?
Yeah. It's a bracket, not a line.
I'm going to show you on this calculator. Right here. Int. INT. That's what that is. So if I want to find the greatest integer, what do you guys think the greatest integer of negative 4.1 is? I'm going to put it in parentheses here.
Tell you.
What do you think it's going to come out to be? It's going to be negative 5. So what is greatest integer? It means you're rounding down. I want the integer rounding down. So here is negative 4, negative 5, negative 4. So where is negative 4.1? It's right here. You're going to round down. So you're going to go to the left. Always to the left. So this answer is negative 5. What if I had 4.9?
4. Or, yeah.
4 is correct. You're going to go to the left. What about negative 2.9?
Negative 3.
Negative 3. What about 10.9999999999999?
10.
10. So greatest integer, you're going to see a letter, X, and it's going to be in a box. You round down. Go to the left. Round down. A lot of people think it's rounding. It's not rounding. You're rounding down is what you're doing. Now on this calculator, let's see if I haven't found the greatest integer yet. It's probably right here. And I don't see, anyone see the box? I don't see it. So,
It's not on the top right of my brackets. I can't see. Just find-
I'll have to find greatest integer on this function, on this calculator. But on the 83s, what you do is you hit math, num,
I
And
found the
it's-
brackets, but it doesn't
int.
round for you.
Where, on this? How'd you find it?
That's by the parentheses, right above it. Control left.
Oh, right here.
But it doesn't solve it for you. It just
It
says,
doesn't do it?
Yeah,
No.
it says like 10.9.
Here's your human argument.
Okay, well, I'll find it. That's the absolute value. Can you hit the, so your homework